Hello, my name is Daniel and I'll go through my balls game I've made for 3D graphics programming and physics for computer graphics. Upon starting, we get introduced with this page. We can press M to start game, and we can then use one of those controls displayed here to basically control the game. For example, we have I for straight throws, O for curved, and we can decrease and increase the power by using minus and plus. And when we're ready, we can press space to throw the ball. So for example, let's set the power to like 8. We can select I and we can throw the ball, and that was actually a pretty decent throw. We can press R to restart and we can try different throws. Now we can have a go at a curved throw. Let's select left and we get something like this. We can press R again to restart and try a different throw. Of course, we can now, let's have a look at decrease the power, and we can try and a right throw, something like that. And then we have different type of cameras which we can have a look at what's happening here, and we can use this to plan our next throw. And finally, if you happen to throw the ball at too much power, you'll actually land in a ditch and will be forced to reset and try again using different powers. In this video, I'll talk about the physics aspects of the game. My acceleration and deceleration work very simple. I used them as constant values, meaning that my ball doesn't get affected by like the mass of friction. I have simply defined the move step, which is 0. All of this is in update as we want it to be constantly updating. Our move step at the minute is 0, so at the start of the game our ball is going to be still at its position, and as soon as we basically adjust the speed of the ball, so for example the powers, which I'll get into later, but as soon as you adjust the position of the ball, it will move towards the heading, so whatever direction we turned it, and then by the move step. So if your power is 2, it will move the position by 2. However, it will not get straight to 2. It will gradually increase to 2, which creates acceleration effect, which is right here. So if move step is less than 0, it will actually add a fixed value of this much till it reaches its max, which is the 2. Once it reaches the max, it will then start decelerating at this value. I'll now explain my the adjustment of power, the decreasing and increasing, so you can understand better what I have to say later on. Simply what you do, this is still an update function, so when the plus is pressed, it will increase the speed variable, which by default is 5. So at the start of the game you have this a default power of 5, and then you can adjust it from there. Either by pressing plus, it will increase the variable by 1 every time you press it, or decrease it. I have then did a function, throw ball. This gets called every time you press space. Basically we set the speed from 1 to 10. You cannot go above 10 or below 1. Obviously with minus and plus you get to increase between all these values, which obviously then, for example, when you set it to 7, it will set the move step, which is by default 0. You can then change it to this value, and upon pressing space this will get called and it will go to number 7, set that, and then our function acceleration and deceleration will take over with this value. This is what it looks like in a game. The stuff I so far explained to you, this is what it looks like in a game. Basically you can adjust the power level. So for example that will set power level 8 will set the move step to 0.080, I believe. and when we press space, it will do the acceleration and then decelerate once it reaches the power level. Something like that. As you can see, it accelerates and decelerates. So now I will try and explain how my curved rolls work. Basically what's happening is, I've already explained what throwball is. It's basically referring to the move step I've done. So depending on what you select, it will first throw the ball. Additionally to this, we have this function which actually does the roll, the curve, sorry. Basically, whatever we set the move step to, for example, if it was 7, it will be 0.07 here. And basically, if it's less than 15, we want to do the curve. The reason is not 0, basically till it stops, is just to make it look more realistic. If it was 0, the ball would be curving too much at the end, which doesn't look really realistic. The rotation angle is just a variable of 0, and turning speed is variable of 90. This will track the speed at which the ball turns at, and this is just a 0. So this is actually, believe that's the curve to the left, and this is it will take away the 90 from 0, and it will do over the time till it reaches almost the stop of the ball. And we do that with this update of position all the time. So it will apply the acceleration and deceleration with the curve. We also divide it by delta time. The reason for that is we want to create a realistic curve. By dividing it by delta time, we create basically a curve more realistic, like this, something like this, instead of something like this, which would seem wrong. The overthrow is basically exactly the same. It's just that it will add, so we will go into the positive rotation angles instead of the negative. And now onto the colliders. The colliders work very simple because it's not the ideal colliders. In fact, I'm using colliders called inelastic collision. Basically, it's collision between two objects such that after the collision both stick to each other and hence move with the same velocity. Let's just talk about the x position, since the z position is the same. Basically, if the x position of the main ball is smaller than x position of other game object, the main ball's position will be taken away by the speed at which they impacted, and the other object will have the opposite reaction to the main one. And obviously, if it's the opposite, it will do the opposite reaction. And it's same with the z-axis. And for the trench collision, we actually don't have collisions, but we do have the ball react when it reaches the trench, which is at this position of z. This is where the trench begins, and once the ball reaches this position, it will basically go down to the ditch and it will get stuck, which is move step to 0. And this is what our collisions look like in the game. I hit the ball, they will all actually react to each other. So if one ball hit another one, they will actually push each other. In conclusion, I am really happy of all my physics aspects, to be honest. Everything's working as intended, except the sphere colliders. They could have been implemented a bit better and actually have proper reaction when they hit each other, meaning they will bounce off each other when I hit them. But other than that, I am happy, and here are my references.